So based on the instruction set, the microcontrollers are classified into two types, CISC and RISC. So such type of microcontrollers in CISC, I'm talking about the CISC. In CISC, the microcontroller CPU is designed to execute a single complex command. It can execute multiple instructions or steps using a single instruction. The advantage of CISC microcontroller is its small sized program, but due to the large size of its instruction set with many addressing modes, it takes a multiple machine cycle to execute and causes longer time to perform. And another problem with the CISC is the parallel execution of instruction, which is not possible in the CISC microcontrollers. So what by complex instruction, what I'm trying to say is that a complex instruction set is made from combination of multiple instructions. That is, to execute a complex instruction, the microcontroller needs to execute various simple instructions. So these instruction set are used for instruction that contains several steps, including the use of several functional blocks. So next is RISC, that is reduced instruction set computer. So this type of microcontroller CPU is designed to execute smaller simple instructions. Since it takes one machine cycle to execute a single instruction, the number of machine cycles can be reduced to execute a complex task with higher speed than a CISC. So its instruction set size is small, and the program code written for such microcontrollers are usually very lengthy and consist of many lines. So this is one of the drawback of this RISC microcontrollers, that the program code written for these microcontrollers are usually very lengthy and it consists of many lines of the program code. Now next classification of microcontroller is on the basis of microcontroller architecture. That is, the microcontroller architecture is a set of rules that defines the functionality and implementation of a microcontroller. So the program memory is used for storing and accessing the code or the instruction, while the data memory is used for storing and accessing the data used by these instructions. There are two types of architecture that differentiate from each other on the basis of using a single or separate memory for these data and instructions. Here I have shown also the Harvard architecture based microcontroller has physically separate memory storage for program code and the data, known as the program memory and data memory respectively. Thus they have separate bus lines and can be accessed both at the same time. Therefore the Harvard architecture based microcontroller can complete instruction in one machine cycle. Now, due to the two physically separate bus lines, the complexity of microcontroller design and the development cost increases, and they are mostly used in modern microcontrollers and digital signal processing units. The next classification under this basis, that is architecture, on the basis of the architecture, is von Neumann architecture microcontroller. So von Neumann or Princeton architecture, it suggests to use a single memory for both program and data storage. So this concept was proposed by mathematician von Neumann in the year 1945, and it is the most used architecture in all computers, desktops and laptops to date. There is only one bus required for accessing data and fetching instructions. Thus both operations cannot be done at the same time and they must be scheduled. This is why von Neumann architecture based microcontroller takes 2 machine cycles to complete an instruction. Since it uses a single bus system, its design is simple and production is very low as compared to the Harvard architecture. So this was all about the classification of microcontrollers. We classified the microcontrollers based on the bus size, then based on the memory, then based on the architecture, and based on the instructions. So this was all about the classification of microcontrollers. So I'm ending this lecture here. Thank you.